Hello, welcome back to another video where we are looking at some trigonometric identities and we are applying them to problems that just look a little bit weird. Before I start, let me just remind you of the types of problems that we are working through. So, I say remind you of the identities that we are using. So the identities that we acquired, in addition to the ones that we should already know, which are sine squared theta plus cos squared theta is identical to 1, along with sine theta over cos theta is identical to tan theta. We have also acquired the identities 1 plus tan squared theta is identical to sec squared theta, and also 1 plus cot squared theta is identical to cosec squared theta. So that being said, let's go. Over here, we have cosec x equals k over cosec x, where k is greater than 1. And we want to find in terms of k the possible values of cot x. So where on earth is cot coming from? Well, there is a relationship here that relates cot and cosec. So the question is, how are we going to get a cosec squared? Well, if we multiply both sides here by cosec, we get cosec squared x is equal to k. Cosec squared x is the same thing as 1 plus cot squared x using the identity, which equals k. So therefore, cot squared x is equal to k minus 1. Okay, and now this means we get the cot of x is going to be the positive square root of k minus 1, or cot of x is going to be equal to the negative square root of k minus 1. The fact that k is greater than 1 means that that square root will remain positive, or it will remain doable, because the thing under the square root normally has to be greater than or equal to 0. So that just allows for us to do that. So keep in mind these identities at the bottom, because we're going to use them in the next questions. So next, given that cot theta is equal to minus root 3, and that theta is in between 90 and 180, find the exact values of sine theta and cos theta. So let's do part A. So we know the identity 1 plus cot squared theta is identical to cosec squared theta. And in particular, we know that cot theta is equal to minus root 3. So 1 plus minus root 3 squared is equal to cosec squared theta. So that's 1 plus, minus root 3 squared is just 3, is equal to cosec squared theta. So 4 is equal to cosec squared theta. Let's just rewrite cosec squared theta in terms of sine squared theta, because we're trying to work out what sine theta is. So 4 is equal to 1 over sine squared theta. Rearranging, we get sine squared theta is equal to 1 over 4. Now we get sine theta is equal to the square root of 1 over 4, which equals a half. Now the question is it plus or is it minus? That's the question. Okay, so that's the bit where we need to now use this information to determine whether it's actually plus or minus. So one way you can do this is just do a quick sketch of the sine graph, just a very, very small sketch. And bearing in mind this is 90 and this is 180 here. We can see here that between 90 and 180, the graph is positive, it's in the positive region, it's above the x-axis. So therefore, we know that we've got to take the positive square root. So indeed, our answer is going to be the square root of a quarter, the positive square root, which is indeed a half. Another way you could do it is just to take, on your calculator, just try sine of some value between 90 and 180 strictly, and then check is your answer positive or negative. That will also do. Okay. So let's go on to part B. Well, we now know that sine theta is equal to a half. So we also know that the identity sine squared theta plus cos squared theta is equal to 1, or indeed cos squared theta, rearranging it, is identical to 1 minus sine squared theta. And that tells us that cos squared theta is equal to 1 minus sine squared theta, which we already knew here was a quarter. So therefore, cos squared theta is equal to 3/4. So therefore, cos theta is equal to the square root of 3/4, um, which is √3/2. So again, the question is it going to be the positive or the negative square root? To do that, we can either do cos of some angle between 90 and 180. You can pick anything as long as it lies in the range. If it's positive, it's the positive square root. If it's negative, it's the negative square root. Or we could just draw a graph. Quick sketch, that's 90. 180 is about here. So we see that in between 90 and 180, that lies as in the negative part, it's below the x-axis. So indeed, it is the negative square root. That's it for that question. Let's keep going. Okay. Next, we've been given that tan theta is 3/4 and that theta lies in between 180 and 270. And we need to work out the value of sec theta. Okay, so we know that 1 plus tan squared theta is identical to sec squared theta. Okay, and then we know that tan theta was indeed 3/4, so that's 1 plus 3/4 squared is equal to sec squared theta. So that's 1 plus 9/16 is equal to sec squared theta. And that's going to be 16, that's 25/16, which equals sec squared theta. Now, at this stage, we can take the inverse. So, inverse, well, yeah, the square root. To make it easier for myself, because I know that sec is 1/cos, well, wherever cos is negative, sec will also be negative, right? So I could just think about this as, okay, I know cos squared theta, given that cos is 1/sec, is going to be the reciprocal of this, which is 16/25. So I can think about the square root of cos and think about angles between 180 and 270. So that's going to be that's going to be 90 here, 180 here, and 270 here. And we can see that between 180 and 270, again, it's negative. So therefore, my sec theta here is going to be the negative square root. So minus the square root of 25/16, which is going to be minus 5/4. Okay, so that's that one there. And that's all on the basis that we know the cos graph is negative between 180 and 270. Yeah, 180 and 270. Again, you can always just do cos of an angle between 180 and 270, see if it gives you a negative number, and then that would give you the same result. Okay, well, with cos theta, if we've just worked out that sec theta is going to be minus 5/4, then cos theta is going to be obviously 1/sec theta, which is going to be minus 4/5. So that is all good. And then for sine theta, we can use the sine squared theta plus cos squared theta is 1. Rearranged gives us sine squared theta is identical to 1 minus cos squared theta. And we know cos theta is minus 4/5. So we can say sine squared theta is equal to 1 minus 4/5 squared. So we get sine squared theta is equal to 1 minus 4/5 squared is going to be 16 over 25, and that is going to be 9 over 25, sine squared theta that is. And then sine theta is going to be either the square roots, the positive square root, which is 3 over 5. We just need to check, is it that or is it the negative? Same thing. We are going to draw a graph. So this one, we've got 90 here, we've got 180, and we've got 270. We can see that between 180 and 270, that's going to be negative. Again, you could just do sine of some angle between 180 and 270. If it gives you a negative answer, then you also know that this is going to have to be negative. So we've got our three values. Okay, let's keep going. Let's do one more. So given that cos theta is equal to 24 over 25, work out the value of tan theta. So again, we can still use, still based on the identities, we can say 1 plus tan squared theta is identical to sec squared theta. Just to make that really, really clear, that's 1 plus tan squared theta is identical to, well, sec squared is 1 over cos squared theta. Why have I done that? Well, that's because I've been given the value of cos theta, so now I can put that in. So 1 plus tan squared theta is equal to 1 over cos squared theta, which is going to be 1 over 24 over 25 squared, which indeed is going to be 1 over 24 squared is 576. 25 squared is 625. So that becomes 625 over 576. Okay, so now I can work out that tan squared theta is going to be equal to 625 over 576. Take away 1. And that is going to be tan squared theta is equal to, what is that going to be? It looks like it's going to be 49 over 576. Therefore, tan theta is going to be the square root of that, which is 7 over 24. So then my question again is going to be, is it the positive square root or the negative square root? Well, reflex means between 180 and 360. So 180 is less than theta, which is less than 360. So we can draw a tan graph, or again, just do tan of a reflex angle. I'm going to do the graph because I don't have a calculator by me. So yeah. So this part is going to be 90. This part is going to be 180. This is 270. And then, yeah, this is 180. What else? And then we've got 360 here. Okay. Dun, 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 dun. Ah, no, I know. Okay. Nope, I just realized this part is not right. If cos theta equals 24 over 25, what we need to do is check. Okay. Reflex means between 180 and 360. So 180 is over here. This is 270, and then this is 360. Now, because cos theta is 24 over 25, which is positive, the kind of reflex angle that this would be is here. It has to be because cos theta we've been told is actually a positive value. So in particular, it's got to be between 270 and 360. So I can actually change this range to say it must be between 270 and 360. Interesting question there. So on that basis, because it's between 270 and 360, tan of theta must indeed be the negative, because between 270 and 360, it's negative. Again, you can type in a value that's between 270 and 360. Quite an interesting question, actually, I must say. Okay, now that we've got that information, well, to work out cosec, okay, so we now know that you can use sine theta over cos theta is identical to tan theta. Well, we've already got the value of tan theta and we've got the value of cos theta. So sine theta is identical to tan theta times cos theta. And then once we've worked out the value of sine, well, cosec is just 1 over sine. So that's going to be, so sine theta is indeed equal to tan, which is minus 7 over 24, multiplied by cos, which is 24 over 25. This is going to be minus 7 over 25. And then that means that cosec of theta is going to be minus 25 over 7 because it's 1 over sine and it's the reciprocal. Ooh, interesting set of questions there. That is it for this video, and I will see you in the next one. Take care for now.